this is around the time the idea of deism starts to grow. This idea that there is a God, but God just created everything, put it in motion, and stepped back and wasn't involved anymore. We see an observation. Everything is ordered. Everything, comets, planets, they move on their own. There's a set path for them. And it's not a situation where God steps in at every moment and says, okay, now I'm going to put this here. Now I'm going to put this here. When you see this, the phrase that's used a lot is that God set the universe in motion like you wind up a clock and just let it go.
3, 2, 1. Welcome to Love Machine.
Welcome to another Nerding Out with That Nerdy Catholic. I'm Seth Payne, and I'm here with my co-nerd Cesar, and we are continuing our series on the history of physics. We've got a few physicists we're going to touch on today, but then we're going to be taking a break, and we're going to be going into a series on AI. And this is a topic that people are talking a lot about today, and I think there are a few things that I haven't heard many people talk about, and so there are some really interesting topics that we want to touch on in the area of AI, and coming from two software engineers and people that love tinkering with computers. This is going to be a really great conversation. But before we do that, start that next time, we're talking about a few physicists, and we're looking at physicists that are just into the time of the Enlightenment.
Yes.
So who are we going to start with, Cesar?
So we are going to start with Johannes Kepler, just to close the loop on the belief on the movement on the Earth around the sun. And what comes with Johannes Kepler is he is the one that give us the final demonstration of it is the Earth around the sun. And this is why.
Okay.
Very important. Remember, we got a long conversation on classic physics on how these thoughts of the interpretation around the universe that we live in.
Yeah.
And finishing with Johannes Kepler, he was a German mathematician. He was born in 1571. He's best known to have the correct notion of the planetary motions, that was developed, and also the heliocentric theory of the universe, He was when he was born. Since he was a child, he showed interest in mathematics. So that's kind of a common denominator if you want to be a physicist.
Right.
And science, He studied in the University of Tübingen. Sorry about that. My pronunciation in German is not that good, really. And here comes the first clue here. He became a math teacher in a Protestant seminary of Graz, Austria. But then in 1606, he married Barbara Müller and had 3 kids with her. And but with the 3 kids, only one survives infancy. So sometimes we take for granted that, okay, we have 3 kids, they will all grow up because modern medicine allow us to do that. That was not the case in the 16th or 17th century here.
Yeah.
But he was a very good mathematician and astronomer, because in 1606 he was invited in 1600 he was invited by Rudolf the Emperor, to be the astronomer for the crown.
Wow.
This is in this place, with all the money, with the development of instrument. He started his development of the work on observing the universe and taking more precise measurements to determine the heliocentric theory.
Right.
This with this whole let's say You are serving the king on the crown. You are the astronomer of the king. You have all the facilities you want.
Right,
no?
right.
So that's a very good point here. No. One of the things that that I want to highlight is that although he developed that, and we are talking about 1606, 1607, he developed his heliocentric theory. Until that point, we still believe that the Earth was the center of the universe. That common belief.
Well, that was what most people
the
thought.
common belief, yes.
Yeah, that as we've seen, there were a number of people, a number of scientists and others who had the idea that the Earth went around the sun, but there was no way to prove it. And if you look at Scripture, and if you look at just our everyday observations, there's no reason to think that the Earth is moving.
Yeah.
You think about what's one of the common names that people use for the Earth is terra firma.
Yes.
The firm Earth
Yes.
is solid under our feet. And so if you think about it, now that we know, and now that we've known for hundreds of years that the Earth goes around the sun, it's easy to have a kind of have an attitude that, well, we know this is true. So anyone who believes differently must have been ignorant or unwilling to see the truth.
Yes.
But until you observe, or until you can really see the truth, there's no reason to doubt that, yes, the Earth is firm under our feet.
Yes, I completely agree. And that is, even us when we are little child and say, well, the Earth is moving. Say, no, it is not, because your senses tell that it is not moving.
Yeah.
We have a quote here from Johannes Kepler. I wanted to become a theologian. For a long time I was restless. Now, however, behold now, through my effort, God is being celebrated in astronomy.
Yeah, I love that. I love that quote. It's it shows that no matter what you do, if you believe in a God that created everything, that no matter what you do, it's going to bring glory to God.
Yes.
I had this experience when I was in my 20s, and I was going on a missions trip for the church I was going to, and I had this idea that it's like, well, I'm not a preacher, I'm not I'm not a missionary, and so I felt kind of useless going into this missions trip. And we got there, and we were working with an organization in Nigeria, and we get there, and they bring us to their main office, and there was one other guy who was in an IT department where he worked. And we get to the office, and they said, "Oh, by the way, we have a printer that doesn't work, and we're having some issues with our network, and some other computer issues." And so we're like, "Well, we can help you out with that." No matter what you do, if you do it with the right mindset and spirit, you're going to bring glory to God. Yes. So I love this, that he wanted to be a theologian. So I can kind of understand what is thought here. I wanted to be a theologian because I wanted to glorify God, thinking that, well, if you want to glorify God, you have to do something to do with God, right? But if God created everything, then no matter what you do, and so that that he realized that God was being celebrated in astronomy, because if you're studying the heavens, if you're studying creation, then you're saying, look how ordered creation is.
Yes, look how everything is beautiful and makes sense. I love that idea. No, besides, we have to say that he was a Lutheran as a religious faith, no, but
Mm-hmm.
he was deeply committed to his Christian faith.
Mm-hmm.
He was a scientist, as you mentioned. He wanted to pursue theology, but then he was called to astronomy.
Yeah.
But there was the root, the desire of pursuing God, no?
Yeah, and that makes me think of this other quote that we have here. Before the origin of things, geometry was co-eternal with the divine mind. And we've talked about this before, that the language of the universe is math.
Yes.
And this realization that, I think we've even talked about this before. You look at the Bible, where it talks about God. When God created everything, He spoke.
Yes.
And then you look at what Jesus was called. He was called the Word,
Mm-hmm.
and the Word is in Greek is logos, logic.
Yeah.
So it's logical. It's mathematical.
Yes.
It's orderly, and so this idea that that geometry was co-eternal with the divine mind, because it's true, and it's orderly, and it makes sense, and so there's a logic. So the logic was there.
Yes.
With God.
And I want to highlight something else. No, this is a guy who is a scientist who wants to be a theologian. He pursued in astronomy. He married. He had 3 kids. 2 of them died in the infancy.
Mm.
But even though he never lost his faith, no, because he could go through a path saying, "Oh well, 2 kids has."
How could God take away my kids?
Yes, exactly. But he saw with his studies that everything that he discovered was beautiful, follow a path in order, no, and that was the language of God. He was able to discover that, no, and because one of the things here is that in his writings you can see that he believed that the understanding of the universe was possible because humans are made of God's image. No? And then I like this quote here at the end. The chief aim of all investigation of the external world should be to discover the rational order and harmony which has been imposed on by God and which He revealed to us in the language of mathematics. How beautiful. So this is a guy that, even though one of the biggest pain that a man can suffer, which is the death of their kids, he continued and persevered in his faith. No,
this is one of the main reasons that we're doing these series, and why we're doing this channel, is that this understanding that theology is not separate from math and science.
Yes.
As in the intro to every single video, all truth is God's truth. That and it's not reducing everything to theology. It's saying that if God created the world, if God created the universe, then God created the order. God created this, seen here, the language of the universe, which is math. And that means God is mathematical. God is scientific. God is the ultimate scientist and mathematician. And so Bishop Barron talks about the good, the true, and the beautiful. If you study anything that's good, anything that's true, or anything that's beautiful, then you're studying something that God created.
Yes.
And anything that you study, you can look back and say, wow, what an amazing God to make this order. And as he said, to create us in his image. And one of the aspects of us being created in his image is this creativity, this curiosity, this, God gave us a mind to desire and a mind to desire to understand the universe, and a brain to help us understand the universe.
Yes. talking about understanding the universe,
Yes.
our next physicist is one of the most famous physicists in the history of physics. No,
Yeah.
it's Isaac Newton.
Isaac Newton. Yep.
Yeah. So let's start with Isaac Newton. And Isaac Newton was born in Lincolnshire, England, in January 4th, 1643. He was a mathematician,
Yep.
physicist, astronomer, alchemist. There's that word again.
Yeah, yeah, and as we said before, alchemist is kind of
Chemist.
akin to like a proto-chemistry.
Proto-chemistry, yeah, I like that word better, no? Theologian and also author of books, no? And the best summary that he has, the best book, because he not only write one book but several, but the best one that it's recognized and show his talents in all the light is Principia Mathematica, which was published in 1687. No, so
I mean, he only invented calculus, right?
and that's another thing I want to highlight.
Yeah.
What did he do?
Yeah.
No? Why is he considered the greatest physicist of all time? One of the greatest physicists of all time. No, well, we got several fields here.
Yeah,
In math, he invented calculus. No, although sometimes we have to share that with Leibniz, but there you go. No, he invented calculus from the differential part. Leibniz invented calculus from the integral part. So, but both on calculus on that.
and those are both formulas that really confuse me a lot of the time. The differential and integral.
That's when math starts to be a little more hard.
Yes.
No? That's because of them.
Yes, yeah.
Also in math, he invented the binomial that has his name. No, that's the binomial of Newton is one of the key pillars from modern algebra. No, that's one of the things. In astronomy, he discovered gravity and gave the famous formula for the universal gravity. No,
We've talked about before that even with all of our understandings now of quantum physics, quantum mechanics, anything done on the macro level, you calculating our path from here to the moon or here to Mars, anything of any motion in space, we use Newtonian physics.
Yeah, we are not going to get complicated with relativity and those tensor equations. There's no way.
Now, once we can travel closer to the speed of light, we will have to think about other things. But as far as moving around our own solar system, all we need is Newtonian physics.
Yes, that's right. That's true. So this is the kind of influence we are talking about. Late 1700 here, and we're still using his formula in the 21st century. No?
Yeah.
In mechanics, he gave us the three laws of motion. No? The law of inertia, the formula for the force, no, mass times acceleration, and the law of action and reaction. These are the pillars of classic mechanics. We have to understand this in a better way. We still use this, by the way, when we are building things. No? When we design cars, when we design buildings, when we design everything that has motion or has to support some kind of motion, we still use those three Newton's laws up to today.
Well, and you think about the complexity of the machines and the processes in the last few hundred years and how quickly things have developed. And you think, well, why were they never developed before? Well, you have people like Newton that were just leapt forward in our understanding of the universe so that we could manipulate these understandings to be able to build things that were more complex.
Yeah. And, right now, the simulator, for example, when the engineers want to simulate the buildings and the stress on each component, when they are building a car, those simulator packages has embedded Newton's formula there. And the calculus, there's a name for that, infinitesimal calculus or something like that. So to each point, they apply Newton's laws. No? Just to let you know, it's amazing.
Well, and you think about, now, like, for the shapes of things that we create now are so, you think about, something being streamlined. I have a picture in my mind of, when they're building a new plane or a new car and they put it in the wind tunnel. So they have these very complex shapes. Well, how do you calculate the volume of something in a shape like that? Well, you have to use calculus for that.
Yes, definitely. Not only in that, in optics, he discovered the dispersion of the white light in a rainbow when it passed through a prism, so giving us the modern optics right now. And he also developed a new version of the reflecting telescope, which allow us to look farther from, to the stars, no? So these are just the highlights of what he contributed to our society. What about his religious view? He was a very unorthodox but devoted Anglican. Of course, being born in English in that time, it was the King's
Anglican
Church.
Yes, no. I found this quote and I love it. He says, "He who thinks half-heartedly will not believe in God, but he who really thinks has to believe in God." It shows, like we talked about before, that God is a God of order. And if you really think about it, an order requires something to order it, right?
Yes.
Now, I think when I read this, I one of the things that came to my mind is like, well, how would an atheist read this? And I would say, I would encourage anyone, if you don't believe in God and you read a quote like this from Newton, to say, not to say, well, Newton thinks that I'm stupid because I don't believe in God, right? But I would say read this from the perspective of, allow yourself to believe that there's a possibility of a God, and really think about it. That believing in God does not require a cessation of your thoughts, or your logic. As we've talked about in all of these episodes, we've looked at so many people that anyone in the world would look at and say they're brilliant, and it's not, and their belief in God is not antithetical to their field of study, but their belief of God is tied to their study. That they saw the universe, they saw the order, and then because of that, they believed in God.
As you said, God is the ultimate mathematician. God is the ultimate physicist. God is the creator of everything, and he creates everything in order, in a beautiful language that we call math right now.
And so I know there are a number of people out there on YouTube, on the internet, and all over the place, on both sides of this argument, that either say, well, if you believe in God, then all the scientist stuff, it must be people are just trying to deceive us. Or, well, if you believe in science, then you can't believe in God. It's this argument that, and I think it's easy to hear those two voices and to think, well, it's an either or. And I have to either love science or believe in God.
And that's not true. And that is what I love about this series, because one thing is that, Seth and Cesar say that science and faith are complementary, are two things of expression of a beautiful God.
And there's no reason to have to believe us.
But another thing is Newton, the greatest physicist that, one of the greatest physicists that ever lived on Earth, thinking about that. No? So that's one of the things. I love the other quote that we have here, no? We have to consider that the law of gravitation becomes Newton's best discoveries, no? And he warned against using them to view the universe as a mere machine. Newton kind of, he discovered the laws of the universe. Oh, but beware, do not look the universe just as a mere machine. No?
Yeah.
He said, so then gravity may put the planets into motion, but without the divine power, it could never put them into such a circular motion as they have about the sun.
Yeah.
No? So he what basically he's saying is, we have this we have the discovered gravity, but gravity is just a force that attracts.
Yeah.
Look how orderly everything is. Look the harmony. No, gravity itself couldn't do it.
Yeah.
Somebody has to put it into this circular motion. Because if it's so gravity, there are two pieces, they will just stuck together and clash.
Well, and even with the understanding of planetary formation, and we've observed proto solar systems out there that are just in the process of formation. Even there to say, well, you can look at that and say, well, that's why planets go in a circular motion. But you always have to keep going further back and say there's you look at the I can't remember how many variables now are in the equation of the complexity of our universe. The speed of light, the mass of an electron, all these different measurements that if any one of them were off by a fraction of a percent, then we wouldn't have the universe that we have today.
Yes, exactly.
So the order, as we keep talking about, the order of the universe requires something to order it.
Yes. There's no order if somebody orders. Or things doesn't order by itself.
Yeah.
Otherwise, look at my son's room. It's not going to order by itself. Definitely. Should we proceed to the next one?
Yeah, let's move on.
So we are going to talk about the man that saw discovered the motion of the Halley comet, Edmund Halley.
Yeah, Halley's comet. Yep.
So he was an English astronomer, mathematician, and physicist. No, he was born in 1656, and he is the one that cataloged many southern celestial hemispheres and recorded the transit of Mercury around the sun. No? He realized that similar transit of Venus could be used to determine distances between Earth, Venus, and Sun. No? He not only was there and discovered the comet that gave his name, he was looking at the different planets and the motions there. No? In 1705, he published a book that says a synopsis of the astronomy of comet. No? And he discovered that the same comet that he was seeing at this moment was seen before in 1456, 1531, 1607, 1682, when he probably saw that comet. No? So he said, hey, there is a record of a similar event occurring in these times. The measurements that I have of the path is kind of similar. I think it's the same thing. No? I think it's the same thing. So if that's so, no, and by that time he has also Newton's law and Newton's law of gravity. With that, he discovered the motion, and he said, well, probably this comet will appear in 86 more years, and it will return in 1758.
Yeah.
No? Yeah. That's what he said.
Yeah.
He died before that. But there they go, the comet returned in 1758.
Yeah.
And has been returning ever since then, every 86 years. Yeah. Now and then. No?
Yeah.
So that's one of the discoveries. So Newton gave the universal law of motion, of gravity, and he applied on what he saw there and said, hey, I'm able to make good prediction because of this law.
Yeah.
No? So right now, we not only has an explanation of the universe, we have some accurate way to predict the movement of the celestial bodies. No? So the celestial bodies are not only gods that define where I want to put my star because of my desire.
Yeah.
We discover the order, and because of the order, and because we are able to, we are creating the image of God, we have a mind to read through that. We can interpret and we can make predictions.
Yeah.
No?
Yeah. Well, and as an aside, I can kind of see and understand. This is around the time I think that the idea of deism starts to grow. This idea that there is a God, but God just created everything, put it in motion, and stepped back and wasn't involved anymore. I can understand the development of that because we get this idea. I mean, we see an observation. Everything is ordered. Everything, comets, planets, they move on their own. There's a set path for them. And it's not a situation where God steps in at every moment and says, okay, now I'm going to put this here. Now I'm going to put this here. When you see this, the phrase that's used a lot is that God set the universe in motion like you wind up a clock and just let it go. Now, we don't believe that God just set everything in motion and stepped away. But that order can also exist in a world where God is still involved. But he did. He set the world, he set the universe in motion. And the world and the universe still exist and have to exist through him. But it's not like we've said so many times, a universe where God steps in and does everything just because he wants to.
Yeah.
Without any reason. That God created a universe and said, that came to my mind because even thinking about now, the motion of comets, that it's not only a system of the sun and the planets and the moons, but now we have an understanding of the motion of these, in relation to the size of everything else, these tiny rocks that are hurtling out of our solar system and back in. It's just incredible, like to thinking about to live in this time of all this discovery.
Yeah, and the other thing that he discovered is that the so-called fixed stars were also getting into motion. No, and that's beautiful because it remains out. It goes farther beyond our solar system. That everything, not only the planets in our solar system, has to have some law and order, no?
Well, and as we've said before about the idea that all the work that we do is on the shoulder of giants, when we think about everything we understand now about the universe, about the expansion of the universe, we would not be able to understand it if it weren't for the work of everyone that came before, especially Newton and Halley and everything that they observed and understood about the universe.
Yep. I want to highlight this, the religious view of Halley, because he was born as in the Anglican Church, but he did not particularly think about everything that the Anglican Church was through. So that, even though prevented him to advance into his career to become a Savilian professor of astronomy at Oxford, no, that was due part to that concern. So the church in England was so strong that they say, well, because you are not professing that you believe in the truth of that, you cannot move forward. But even though that was not a tiebreaker for him to say, well, then I don't believe. No, he recognized that that was an issue between the other people that think different from him on his religious view, but that was not a factor that influenced him to say, well, there's no God. No. He recognized that. He recognized that there's an order. He recognized that there was some order behind all of what he see. And then he kind of separated that in his mind. No? We have to take that into consideration, because up to this point, we are not finding a scientific that said, well, because I am a physicist, I don't believe in God. No? Let's talk about Daniel Bernoulli, shall we?
Yeah.
So Bernoulli was born in 1700. No? He was a Swiss-French doctor of medicine and a mathematician and a physicist. No? He is very well known because of the Bernoulli's principle, no? And which he described the relationship between the fluids and the pressure. No? And this principle is the cornerstone of the dynamics of fluids. No? So when we talk about, well, this principle, what it does, what implication has Bernoulli principles? No? So it has implications that goes up to today, even though he set the principle and let the implications go farther away, because he died in 1782, but his principle is used to design the wings of the airplanes today, no? To calculate the speed of fluids in the pipes that we use today, the side flow meters that we use today. We talk about spraying perfume bottles, no? The fire hose nozzles use that principle, and to explain weather phenomena. And also he designed medical equipment to understand the flow of the blood.
I think it's interesting that as someone who's a medical doctor as well as a mathematician and a physicist, the combination, the overlap in those worlds, to say, to realize that a lot of the things that happen within the human body has to do with the flow of fluids.
Yes. And you see how fascinating, again, somebody that study a field, develops some laws, he probably never got an idea of how to design the wing of an airplane.
Right. Yeah.
Do you see that even today we use his principle to make many designs that affects our current life? No? And also, another fascinating thing that probably most people aren't aware of this, but he is the one that developed the kinetic theory of gases. No? And what do I imply with that is, instead of to gas to be a fluid thing, he thought about a gas has to be compound but small particles of something that are separated. So what we see as apparent fluid is actually interactions of those particles. And that it's really amazing view, because first of all, up to this point, nobody saw a particle of oxygen, nitrogen, nothing like that, no? But thinking about that give us the grounds for building what we understand of modern gases, no? And this is kind of a predecessor of modern physics. No? We will see that when we start another series of modern physics. But this is very, very important, that thinking that gases and fluids in general is not something continuous. It's small things interacting with each other give us a different understanding of the matter, no?
Yeah. Well, and it's interesting to think that, like so many things we've talked about, it's so hard to imagine now what it was like before his principle. To think about, well, what's a gas? Well, it's just kind of like this amorphous, to think about a gas without thinking about the particles within the gas. I mean, even, we talk about now It's like, well, if there is a concentration of some chemical in a liquid or in a gas or anything that is as much as 4 parts per million, you need the understanding of that there are particles in the gas to even say, well, what's the concentration of something in that, right?
The other beautiful thing, and I have here, is that in order to study the gas as a movement of a lot of particles, he also get into statistics, no? He developed Bernoulli for people that study statistics. Bernoulli is also known for that. But why he developed that? Because he need the math. So one thing is to study, how many small particles interact with one another. Another thing is to study, okay, this complex system of gas has multiple particles. How do I take an average of what is the average kinetic energy of this gas flow? If I can imagine only small particles summing up and adding up into that.
Yeah.
So how to calculate the energy, how to calculate the momentum of the gas, he used that statistics, and that before calculus he couldn't do that because it is adding up to infinitum some particles that has to be. So it is amazing development on that, no?
Yeah, very interesting.
So one of the things that I want to put out here is that regarding his religious view, we don't know exactly the religious view of Daniel Bernoulli, but we know that the Bernoulli family was originally from Holland and has a strong Calvinist religion. We know that, no? But again, in any part, there's a nice caveat here, no? He has a same kind of conflict with his father, no? His father is if the father's name I didn't record that his father plagiarized his work.
Plagiarized it?
Yes.
Okay. Yeah.
His work that is hydrodynamica, and then he wrote his book Hidráulica and published his book before his son can finish hydrodynamica. No, but then justice is served afterwards when he published his book 9 years later. After at the end they recognized everything was first thought by his son Daniel Bernoulli, and then but that makes tense that relationship, no? So that I guess there's a big conflict inside him, and on that, as we said, we don't know the religious view of Daniel Bernoulli, but what we do know for his writing is that he was very focused on what he did. He never got married. He was solely dedicated to that. And even though he never said anything about, or that we know about God, his only work on how the fluids goes is a testament of his intelligence and give us a new perspective of how in this world we can understand the fluid. How marvelous is this creation of the fluid that we can understand it. And by the way, this is a statistics tool that help us to have some meaningful influence. No?
Yeah.
I want to say that the intention originally was to cover more scientists here, but one of the common denominators that I see between the scientists between the 1650 and the 1850, and I invite you to all our viewers, if you Google, top physicists between 1650 and 1850, you will find no physicist that is atheist for some reason.
Yeah.
You may find,
as you said, he doesn't talk about his faith.
Yes.
But he also doesn't say,
there's no God.
This shows that there's no God. Yeah.
Yes. So during this period of time, you will find no physicist that said, because of this, there's no God. On the contrary, you will find a lot of physicists that has a religious view. And they consider that, their faith and their religion are not in concept, but complementary. No? Even the greatest one, Newton, warned us to say, do not look the universe as a machine, because we have to think about who is the creator of that order. No? The order that we see implies that somebody put the things in order.
Yeah.
And it's not us.
Yeah. Well, and it also shows that I'm sure, I feel like Newton, in saying that, it almost feels prophetic to say, hey, we're describing, we're learning about the motions and how the universe works.
Yes.
And it's almost like he could foresee that if you focus just on what we're learning through science, that you can get to a point where you say, well, this all makes sense now. We can understand it with our minds. Therefore, all this stuff just kind of happened on its own, as like you said, as a machine. Therefore, we don't need God.
Yes, that's kind of a prophetic view. And I was thinking a lot about that. By the way, I randomly choose 1650 to 1850 just to give us a period of time. But it happens that, in the 1850 happened so many things, no? Darwin was working on a theory of the species. No? On the other hand, Karl Marx was getting into his ready to publish the Communist Manifesto, no, and Karl and Engels were starting to propose an idea of religion is the opium of the people. No? So something happened, and something has been kind of at the end of this period being elaborated a thought that was contrary to the way of thinking of most of the physicists up to this point. No? It was kind of at the end of this period of time, there was the seed being placed in the scientific community. No,
you think about the other things that were happening in that time. You have, I would say you started here at 1650, but I would say even going all the way back to the early 16th century, you have the Reformation, but also you have what was one of the main technical reasons behind the Reformation, and behind a lot of the things at the time. You have the invention of the printing press. You have this ability to mass produce ideas. You have the Enlightenment. You have the Renaissance. You have this explosion of ideas, and I think that I think you can look at that period and say this is the beginning of this time when, I think Newton really was prophetic in saying, if you up to this point, without the understanding of how things worked, you had to say, well, I'm not sure what's going to happen. I have to trust God. And this explosion of ideas, it makes it easier to say, well, I understand everything there. I understand everything that's going on. Therefore, I don't really need to trust God. And even if I believe that God is out there, like as we were saying before, the rise of, I took a class in college, and it was looking at the development of the worldviews from after the Reformation to the modern time, and it was looking at this almost in my mind as I was studying it, this logical progression of from theism to this idea of deism. It's like, well, God's there, but he's not really involved. But from deism, even if you think that there's a God, if you think that he's not involved, well, it's not that hard to say, well, let's just take God out of the equation.
Yes.
And this motion of, well, I understand everything, therefore I don't need God.
Yeah. And you know, it's funny that you say that, because I understand everything, because we haven't touched on him yet, and I think we will touch when we start the series of modern physics. But Maxwell, when Maxwell discovered and placed his four famous equation, and relating how electricity and magnetism are two things of the same, two faces of the same thing. And how light is an electromagnetic wave. Like everybody said, oh, we discovered the whole world. We kind of understand everything, and that was the period of time that, in hopes, humanity feels like we know what we need to know.
Yeah.
And that's just in light of, I think it's between 1850 and 1900, when that period of time in Europe there was what is called the Belle Epoque, which is a nice place between no major wars, when everybody feel that we have kind of some peace, we have everything discovered now. So that was a good, let's say, groundbreak to say, well, maybe there's no God. We have, as humans, we have figured it out.
Yeah.
No?
Yeah.
And that's a wrong place to start.
Yeah.
And then suddenly we got, we are going to talk about that in another series, but suddenly we got some events that say, hey, there's something that we haven't discovered yet. No?
Yeah.
I think it's time to end this.
Yes. Well, this has been such a great series. Like with the series we did on math, it has been it's been very enlightening and very eye-opening to focus on such a long period of history, but doing it through individuals.
Yes.
Their contribution, and once again realizing that everything that we know now is because of individuals who just took one more step in working at understanding how the universe works. And as we've said a few times today, with the understanding that the universe makes sense, and there has to be a reason why the universe makes sense, right? And that their belief in God went hand in hand with the work that they did.
Yes.
Yeah, and I would say, if you're watching this and you are in a place where you're like, well, I don't really know if God exists, and up to this point, I really have not thought about God. I'd say take that question about the order of the universe, the fact that it makes sense. Just spend some time with that and think, well, maybe there is a God that put order to it.
Yes, definitely.
So, well, as we've said before, we are taking a break, and we're going to be spending a while looking at AI from a few different perspectives. But I think we're going to have some really interesting conversations, so I hope you come back for that. I want to remind you, if you go to thatnerdycatholic.com, you can sign up for an email list to get updates on when we're doing new things, what we're putting out, and just things that are happening in the Nerdy Catholic universe. If you go over to thatnerdycatholic.com/merch, you can get cool swag, Nerdy Catholic logos. Also, we got some fun nerdy t-shirts there. If you go to thatnerdycatholic.com/support, you can help us financially, and we want to thank everyone that has been helped so far. And we just want please share this video, subscribe, and if you have any thoughts, any comments, any questions, anything that we got wrong, any mistakes, Cesar and I know that we are not perfect, and we are definitely not professional scientists. So if you have any Any thoughts or questions or corrections, please leave them in the comments below. We want this to be a conversation. We're not here to say we are the experts and we have all the answers, but we want to be part of a conversation. So leave your thoughts in the comments below and come back next time.
Yep.
Right. God
See
bless.
you next time. Bye bye.
System shut down.